Hello, my name is Safakhan. Thanks for watching. This is a third-person camera clipping tutorial for Unity 3D. So in this tutorial, all that we're going to cover is making sure that our camera doesn't go through terrain or walls or other objects that it's not meant to go through. Also, it's going to make sure that there's nothing directly obstructing the vision between our camera and the character. So let's see what I've got here in this scene. It's this terrain with some trees. I've got this wall to test collision against, and obviously our main camera and the character. So the character is driven by this custom third-person character controller script, which we're not going to be covering because it's arbitrary. Doesn't matter how our character moves around. We just want to make sure that the camera isn't going through walls and stuff. So we've got this child to our character, which I call the camera pivot. And this is going to have our camera controller script on it, and that's going to be the script that we're going to be working with. That script's going to be available in its completed form on my website, safakhan.com. I'll have a link to that in the comments. So, yeah, we're going to be using a couple of methods to achieve this camera clipping. So the first one is going to be a ray cast from our camera position to the pivot, and that's going to make sure that there's nothing obstructing the vision directly. And if there is, then we're gonna move the camera to the collision point that's closest to our character. So for example, if we were in this situation where we've got this hill blocking our vision, we'd move to about there, and then we'd have clear vision. So we'd go right up to there. And the second thing is we're going to make sure that there is no bleeding over the corners, and that's that we're going to talk more about when we get there, because I want to finish the first thing. That way we have visual representation, and you can see why we will need to do that. So another thing that I want to go show you is because we're going to be using raycasting, I have a couple of custom layers here. One I named clippable, the other one is not clippable. So in your project, you probably want to have name them other things and then just assign them each separately, which we'll go over in a minute. But I'm just going to show you how to do one of each, whether we want the camera to be able to clip it or not. So what I've got it set up now is the terrain is clippable, the trees are not clippable, and then the character itself is not clippable, and the wall is clippable. So pretty much our camera is going to clip the terrain and the wall. Okay, so let's get familiar with the camera controller script that I've got. I pulled this from one of my projects, so it's fairly customized, but let's just go over it. And so again, you should be able to use these methods in your project for whatever camera controller you want, but I will have this camera controller.cs script available on my website, and so you could check that out in the link below. So we're going to cache some values, and we're going to do this all in on enable. I've got a few different rotation variables for rotation speed, because I've got two ways to rotate. One is the camera just purely orbits around the player or the character, and there's some clamping that we'll do on the x-axis to make sure we don't kind of flip around. And then the other one, the character itself is going to rotate with the camera. So if you left click, it's a pure orbit, and then the right click, the character will rotate on the y-axis, and the x-axis will still be orbiting the character. And then this is zoom stuff, so use the mouse scroll for zooming in and out, for as like that. And then smoothing the movement, and the last thing is the camera reset. So in the project I've got a reset camera button, and we'll use that to reset the camera to its default position. Alright, so let's create a layer mask that our rays can use to determine what they should, layers that they should ignore, or layers that they should clip with. So we'll just define that in on enable, so mask equals, and then we're going to use bit shifting, and bit shifting might look tricky at first glance, but it's actually really easy. You just put a 1 or a 0 in there. So 1 is for layers that you want to clip with, and 0 is for layers that you want to ignore. So we'll do 1, then shift over, layer mask dot name to layer, and the one that we want to clip with is we named clippable, and then we'll do another one for not clippable, and this was 0 because we don't want it to clip, so layer mask dot name to layer, and then this is not clippable. Alright, so and then you could just keep doing as many of these as you need for each layer that you have, but for us we just have 2 layers, one named clippable, the other one named not clippable. Okay, so we're about ready to do our raycast, so let's go down to after the zoom, but before the camera smoothing. We'll do central ray. And then let's cache a couple of values. So we want to create a new float called unobstructed. And this we're going to set to whatever offset is. So this value is what we're going to be using to determine where the camera should be placed. So right now it's just being placed to whatever the zoom offset is, away from the pivot. So pretty much, so right now it's just saying like, okay, our zoom offset is whatever it is. So like zooming in makes it less, and zooming out makes it more. But so we want to make change this variable if there's something in the way. So instead of using offset, we're going to use this new unobstructed variable. So as you can see here, the desired position is using offset. Let's change that to unobstructed. So now it's just moving it to however far the unobstructed is. Alright, and then one more thing that we want to cache is where it would have been, right? So where that desired position was without any obstructions. So we'll call this ideal position, and then this will be we will use pivot dot position, or actually we'll do transform point, and then we'll do vector 3 dot forward times the offset, right? So this is just like, so the offset is a negative number, so it's going behind our pivot. So this is pretty much just the same number that this was before. And so now we have like the position that it would be if there is no obstructions, but now we want to change this and actually use that change variable. So let's cast a ray. First let's get a raycast hit called out, or sorry, hit, and then we'll do a line cast. So if physics.linecast, and then we'll do it from, so we'll start at the pivot, so pivot.position, and then we'll do it to the ideal position. And then out hit, and we'll use our layer mask, mask.value. Alright, so now if it actually does hit something, so since we're doing it from the pivot to the camera position, or the ideal camera position, we're going to set the camera to the first obstruction that it hits. So we'll do, we'll change unobstructed to whatever the distance from the hit is. So, and we're actually going to make it a negative value because we want a negative value because we're going to use vector3.forward and go from there. So we want to go backwards. So we'll just change that to negative. So, and then we'll just use hit.distance. So negative hit.distance, that gives us a negative position. And yeah, so now if we go back into our project, you can see that the camera, instead of being moved to the ideal position, it's just going to the nearest obstruction point. Alright, so that's great, but as you can see, there's still some camera clipping involved. Like if we go too close, this wall just completely disappears, or like we'll get like bleeding in the corners, especially in a widescreen. Like using widescreen. So yeah, our second method that we're gonna use will actually alleviate this, and that's going to be pretty similar to what we're doing. So let's take a look. This is our camera position here, and this is the viewport. So the problem that we're getting right now is there are things getting in the way of our camera and viewport and just kind of clipping the sides of it, and that's what we're seeing, where things are just like halfway disappearing and all that. So what we're gonna do is we're gonna similarly to what we just did, we're gonna cast rays, but instead of to the pivot, we're just gonna do cast rays from our camera position to actually each corner of our viewport. And then we're also going to do the centers here, like the center of each side. Alright, so we need to convert each of these sides of our viewpoint, each corner, and the center of each side into world space. And to do that, we need our near clip plane value from our camera. And yeah, so let's go to the bottom of our update, and we'll store that. So float, and we'll just call it C equals my camera dot near clip plane, and then yeah, so now we could just have a vector3 position for each one of the positions that we want. So we want the 8 positions. So we'll do position vector3 position 1 equals my camera dot, and it's going to be viewport to world point. And then this takes in a vector3, so we'll do new vector3. Alright, and so vector3 is, as we know, taken 3 floats, and the third float is going to be our clip plane. The first 2 represent x and y on in our viewpoint, our viewport. So the x and y position, so between 0 and 1. So for example, this corner is going to be 0, 0. this side is going to be 0.5, and this corner is going to be 1, 1. So we'll just do that for each one. So position 1 is going to be that 0, 0. Position 2 is going to be 0.5 F 0. Position 3, 1, 0. Position 4 is going to be 0.5. So 0.5. We don't need 0.5 because we're already doing that with our center ray. But this will be, so this is 0.5, and then 0 or 1.5, 0.5 F for position 5. Position 6 is going to be 1, 0, or I'm sorry, 0, 1. Position 7, so 6, 7 is going to be 0.5, 1. And last but not least, we got position 8, which is 1, 1. Alright, so now that we've got all the positions, let's get a visual representation of it by doing draw line, or debug.drawLine. And we'll do it from our cam transform dot position, and we'll do it to each one. So position 1, let's give it a color dot yellow. Okay. So 2, 3, 4, 5, 6, 7, 8. And let's check that out. So now these are the rays that we're going to create, one for each of these from our camera position to that. And then if any of these collide with anything that is not being masked, then we'll just nudge the camera forward a bit. And then we'll just keep doing that until it's not colliding with anything. So yeah, so we'll do that in a while loop. So let's put all of this into a while loop. So while, and then we need to create a boolean bool. We'll just call it clip, and it'll start off as true. So we'll do while clip. And then you do this stuff. But we want to make sure that we can turn clip off if nothing is being clipped. So, but first we'll just do physics dot line cast, and we'll do it from the this one will start at the camera transform dot position. So cam transform dot position, and we'll go to each position. So position 1, out, hit, and so we'll just use the same raycast hit that we were using earlier. We'll just overwrite it, but we're not going to be using the position that we get from it. And then we'll use the same mask.value. So, and then for here we'll just do clip. So we're not going to do anything if it hits. And then we'll just do else if. This will be position 2. And 3, 4, 5, 6, 7, 8. Else, so if nothing is clipping, we'll turn clip off. So clip equals false. So let's just set these up really quick. So 2, 3, 4, 5, 6, 7, 8. Alright. Now to finish off our while loop, we want to nudge the camera forward if it actually is clipping after all this. So if clip, we'll do cam transform, so our camera transform dot local position. That's important. Local position plus equals cam transform dot forward. So we're going to move it forward by, and we're just going to do whatever the near clip plane distance is. So we'll nudge the camera position to where the viewport starts, and then so the viewport start will be that much farther. And this is pretty arbitrary. I mean, you want to move it forward enough to make a difference, because you don't want to be running this while loop, 1,000 times each frame. But like, it's I mean, you could even like do half of this and it might be okay, but I'll just do it to whatever I hard coded it. I'm just going to do C, which is the near clip plane. Again, that's arbitrary. Play around with that. Different numbers. There is one thing that I forgot to add here. If we go back to our central raycast, the middle ray that we were casting, we need to add a micro value to this obstruction point. So we'll just do 0.01f. So add 0.01f to this value, and that will make sure that we're not putting the camera directly onto whatever wall we're clipping, and that way our wall, these rays will be able to detect that same wall, because if they're casting from that wall's position, then they won't be able to detect that wall at all. So now if we test it, you can see that we can't, our viewport will never enter the wall. So yeah, that's it. Let's just show you what that second method, the while loop, is doing. You can see that we've got the initial position from the wall point, and then it's just nudging it forward this many times per frame. So 1, 2, 3, 4. It's running 5 times per frame, which isn't that bad. So it's just like, depending on how much obstruction there is, like how far it needs to go forward. So yeah, I mean, it feels pretty natural. Like we're not getting any wall clipping at all, and yeah. So check that out. I'm gonna put the script up on my website, sophicon.com. The link is in the comments or in the description, and yeah, thanks for watching. I hope it works out for you, and leave any questions in the comments.